Hello and namaskar. Yeah. So now let's move toward our next topic and basically our next chapter, that is straight line. So straight line. Before beginning with the straight line, okay, let's understand the rectangular coordinate system. Okay, this is basically a 2D system. Okay, this is 2D system. So here we have x-axis and y-axis. So you are familiar that this is x-axis. This actually this is x-axis, this is y-axis, this is x dash or negative x-axis, and this is y dash or negative y-axis. Okay, so when we have to write the coordinates, okay, point is basically what? Point A. If we talk say point A, that is 2 comma 3. So here this is the x-axis and this is the y-axis. Okay, so in first quadrant, if we have to write any point, okay, let's say this is the point. Okay, so this point will be, let's say 2 comma 3. Okay, so you can see that here every point in this region will be having sign plus plus. Okay, in this region, in quadrant first. Okay, this is called quadrant. Okay, so in first quadrant we have every point in plus plus form. Same in second quadrant, we have as we write first x and then y. Here you can say this, in this x is negative and y is positive. So in this coordinate, x will be negative and y will be positive. Okay, so if we have to write any point b here, so this will be nothing but -2 and 3. Okay, now when we talk about quadrant 3, here you can see that x-axis is also negative and y-axis is also negative. So here every point belong to this coordinate will be negative. Okay, so this will, let's say 2 minus 3. Okay, let's say C point. Okay, and similarly here, what you can see that x is positive and y is negative. So we write uh, first we write like x and then y. So x will be positive and y will be negative. Okay, and if we write any point here, then this can be like 2 comma minus 3. Okay, so this is basically our 2D rectangular coordinate system. Okay, now let's move towards some more about this rectangular coordinate system. Okay, so here is the distance between any 2 point. Let's say we have a any 2 point. Okay, let's say A is something but 2 comma 3 and B is something 3 3 not 3, let's say 5 comma 6. Okay, and we have to calculate the distance between these 2 points. Okay, the distance between these 2 points. So how we will calculate the distance between 2 points? So here we have a formula. Okay, here this is the formula, that is distance of 2 point is nothing but the under root of x2 minus x1 whole x2 minus x1 square plus y2 minus y1 square. So this is our nothing but x1 y1, and this is our x2 y2. Okay, so if we find the distance of that, so we know that x1 is what, 2, y1 is what, 3, same, x2 is what, 5, and y2 is what, 6. So distance AB will be nothing but root under, okay, y2 minus y1, or let's say x2 minus x1. So 5 minus 2 square plus 6 minus 3 square. Okay, and when you calculate and find the answer, that will be our distance. So it will be 3 square 9 plus 9, and that is root 18. So this is our distance. Okay, so this is how we use this formula. We use this formula. Okay, this formula to find the distance between any 2 point. Okay, now let's move toward our next formula, that is the section formula. Okay, so section formula is used to finding the ratio in which a third point, okay, let's say we have 2 points here, uh, A and B. Let's just anything like 2 comma 3 5 comma 6, and let's say there is a point C. Okay, there is a point C on this line. Let's say 4 comma 3. Okay, there is a point on this line 4 comma 3 which divides this line. Okay, this line in ratio 2 ratio 1. Okay, so how we will find, we are not given that, suppose we are not given this point, but we are given that the point xy divides, let's say this is some point xy which divides this whole AB line in 2 ratio 1. Okay, so what will be this point? Okay, so in some cases we have to given this point and we have to find the ratio. Okay, so we will use section formula there. Okay, we will use section formula, that is if a point px, or say for this case let's say cx comma y, okay, internally cuts the line segment AB. Okay, internally cuts the line segment AB which connects two point x1 and y1 and x2 and y2. Okay, x1 and y1 and x2 and y1 in ratio m ratio n. Okay, so then the value of x and y will be this. Okay, and if the point connect like point bisect externally, okay, this is the case in which point p x comma y is cutting the line internally. Okay, but if the line cuts externally, then this we have to use this formula in this case, but at the place of plus we have negative sign. Okay, what do we mean by internally and externally? Okay, so this is the point. Okay, so if we have a line, let's say this is a line. Okay, and a b and this is point C. Okay, so this is what m and this is n. Okay, m ratio n. So this is basically internally. Okay, internal bisector. This is internal bisector. Okay, and when we talk about externally, this is something like we have this line a comma b. Okay, and the m ratio is nothing but the extended line. Okay, extended line, this one. Okay, so this is m and this ratio is n. Okay, so this is what basically externally means. Okay, just like have a rational number at 2 by 3 and in some cases we have 5 by 3. Okay, so this is internally and this is externally kind of thing. Okay, you can relate this thing with this. Okay, now let's move toward our next topic, that is the area of triangle. Okay, area of triangle. Okay, so if we are given 3 points, let's say x1 y1, x2 y2 and x3 y3. Okay, as triangle, for forming a triangle we need actually 3 sides, right? So x1 y1, x1 y1, this is x2 y2 and this is x3 y3. Okay, so if we need to find the area, okay, area of this triangle, if we need to find the area of this triangle, okay, so we will use this formula, that is area. This is known as del. So area, basically this is area, this area. Okay, so area will be what? X 1 by 2 modulus, okay, modulus x1 into y2 minus y3. Okay, x2 into y3 minus y1 and x3 y1, okay, minus y2. For ease to remember, you can see that here 1 2 3 2 3 1 and 3 1 2. So basically this is what? Rotating. Okay, rotating between both the ends. Okay, 1 2 3, then 3 came at first, so 2 will be there. Okay, so this way. Okay, this is rotating. Okay, yeah, so this is how you can use this. Okay, okay, so let's move. You can see that we have used modulus here. Okay, we have used this modulus. Why we have used modulus? Because when we talk about area or area, then we know that area is always positive. Okay, there is nothing, no area can be in negative, so we use positive to avoid that negative sign. Okay, so as area is always positive, so we use modulus. Okay, and we have a study of models, how what modulus do. Okay, now let's move toward our next topic, that is the slope and the main topic about the straight line. Okay, so from here the basically the straight line starts, that is the slope of line. Okay, so basically what do you mean by slope? Okay, so slope means nothing but the steepness of a line. Okay, how much a line is steep. Okay, steepness is basically what, the angle. Okay, how much this is inclined. Okay, so that is what basically slope means, how much it inclined. Okay, so if we see this graph, okay, so here is a line, okay, forming theta angle with this is the coordinate system written wrong. Okay, so this is basically y-axis and this is x-axis. Okay, so here you can see that this is point x1 y1 and this is point x2 y2, and we will find the slope. Okay, so slope is nothing, we represent slope by m. Okay, we represent slope by m, and slope is nothing but change in y by change in x. Okay, this is nothing but change in y on change in x, that is what we have written, that del y upon del x. Del is basically represent the change. Okay, so change in y. So how do we find the change in y? So change in y is nothing but the y2 minus y1. Okay, so here y2 minus y1 upon change in x is basically what, x2 minus x1. Okay, so this will result a slope. Okay, and slope has also a link, a relationship with the angle. Okay, so basically slope is nothing but the tan of that angle. Okay, so m is basically tan theta. Okay, so for finding the slope, we can, if we have given the angle, if theta is given, okay, so we can use m equals to tan theta. Okay, and if we are given 2 points, let's say a equals to a comma b and b equals to c comma d. Okay, we have given, if we have given 2 points, okay, and we are said to find the slope, then we can use this formula, that is this one. Okay, we can use this to find the slope. Okay, so slope here in this case, it will be nothing but d minus b upon c minus a. Okay, so this is how we find the slope. Okay, and slope is nothing but the steepness of a line. Okay, inclination of a line. Okay, now we know about the slope, so let's see some important properties about the slope. Okay, so the property, basically by using the slope we can identify that the two lines is parallel to each other or perpendicular to each other. Okay, so let's say we have a line L1. Okay, let's say this is the L1 line and this is L2 line. Okay, and let's say slope of this line is M1 and let's say slope of this line is M2. Okay, so if we get M1 equals to M2, if we get m1 equals to m2, then we will say that the line, okay, both the line are parallel to each other. Okay, if we get this thing, this condition is valid, then we can say that the both lines are parallel to each other. Okay, so here it is written that let L1 and L2 be the two non-vertical lines, okay, which with slope m1 and m2. Okay, m1 and m2 with inclinations alpha and beta. Okay, the two non-vertical lines L1 and L2 are parallel if and only if their slopes are equal. Their slopes are equal. That is the M1 is equal to M2. Okay. Same if we have this line, this kind of line like perpendicular line. Okay. Okay. Let's say this is a perpendicular line. Okay. So let's say this is L1 line and this is L2 line. Okay. So two lines will be perpendicular if, let's say, m1 is its slope and m2 is its slope. Okay, so these will be perpendicular if we get m1 into m2 is basically minus 1. Okay, so let's say if we have m1 as 2, okay, and m2 as minus 2, okay, minus 1 by 2, okay. So we can find that m1 into m2 is basically nothing but 1 minus 1, okay. That is basically 2 into minus 1 by 2, and 2 will be cancel out and we will get minus 1. So we can say that the lines which have this slope and this slope are perpendicular to each other, okay. By using this thing we can also find the slope of line perpendicular to any line, okay. Let's say we have given a line L1, okay, and we want to find the and it has, let's say, slope m1, and we want to find the slope of line perpendicular to this L1, that is, let's say, L2 line. So we can find using this thing, like, that is m2 equals to nothing but minus 1 times m1, okay. So basically what we have did, that just reverse the reverse reciprocal the m1 and multiply with a negative, okay, and you will get the slope of this line, okay. So by these two conditions you can find the line respective to their condition, okay. Now let's move toward our next topic, that is the equation of a straight line, okay. Now we have learned about the slope, okay. We now know about the rectangular coordinate system, rectangular coordinate system, okay. So now let's move toward basically our main topics, that is the equation of the straight line, okay. What will be the equation of the straight line, okay. So here we have a equation, a general form of equation, or say this is known as the slope intercept form of equation. This is what basically y equals to mx plus c, okay. Here the y is the point, okay, x is also a point, and m, you very well know that m is what, slope, okay. M is what, slope, and here c is the x intercept, x intercept, okay. That's why this is known as slope intercept form, okay. So here so we have to find the, if we have to find the equation of a line, okay. Let's say any line we have given with, let's say anyone say that a line having slope m equals to 2 and uh, it have a intercept of, let's say, 3. So what will be the equation of the line? Then the equation of line is nothing but the y equals to mx, okay. So m is 2, so 2 times x plus c is basically 3, okay. So this will be what, the y equals to mx plus c will give us a equation of a straight line, okay. Next we have up, there are many types of many ways by which we can write the slope, okay. And the next way is nothing but the point slope form of a straight line, okay. So by the name we can see that it is the point and slope. So if we have given a point, let's say a, okay, 2 comma 3, and we have given the slope, let's say 3, okay. So when we have a point and a slope, then we can use this equation to form the equation of a straight line, okay. This is what y equals to y minus y1 equals to m into x minus x1, okay. By using this we can form the equation of a straight line, okay. So let's say if we consider this condition, so we have slope m as 3 and x1 as 2 and y1 as 3. So our equation of line will be y minus y1 is what, 3 equal to m is what, 3, x minus x1 is basically 2, okay. So this is basically what, y minus 3 equals to 3x minus 6. So this will be 3x minus y, and this will go this side with plus. So minus 6 plus 3 is minus 3, okay. So this will be the equation of the straight line, okay. So good. So by using this equation you can find the straight line, okay. In this what we have, a given slope and a given point, okay. Now let's move toward our next condition, what if we have 2 points but no slope? Like we have given 2 points and we don't have given the slope, and we are set to find the equation of straight line. Okay, so you remembered we just studied about the slope. Okay, we just studied about the slope. So how we were finding the slope? We were finding the slope using the 2 points. Okay, 2 points. Remember, 2 points, and we how we find the slope is basically slope is nothing but the change in y upon change in x. So here also, if we are given 2 points, okay, so we can find our slope. We can find our slope using that formula, change in y upon change in x. Okay, and we have found our slope. We have found out our slope, and we have 2 points. Okay, so we can use any point, 1 point, and a slope to find the equation of a straight line. Okay, here we have a slope and a point. Now we have 2 points. Okay, we have 2 points, and we don't know slope, but we can find the slope. And when we can find the slope, we will have a slope and a point. Okay, so we can use in that case we can use that point slope form. Okay, but if you don't want to do that, then you can use this formula. Okay, here you can see that this is nothing but the equation to find m. Okay, so and remaining are same. Okay, so if we replace this m, so this is nothing but this one, which is a point slope form. Okay, okay, where m is nothing but m is y2 minus y1 upon x2 minus x1. Okay, so I think this is clear. Now let's move toward our next topic. Okay, that is the angles between the two lines. You know that when two lines intersect each other, then they form angle. Okay, they form some angle. Okay, so what will be the angle? If we are finding the equation of the line, then we can also able to find the angles of those lines. Okay, angles between those lines. And for finding the angle, we use their slopes. Okay, so here you can see that let L1 and L2 be a two lines. Okay, with slope m1 and m2. Okay, L1 has m1 slope and L2 has m2 slope, and inclination is alpha 1 and alpha 2. So okay, so here is inclination alpha 1 and here is inclination alpha 2, and let us assume alpha 2 is greater than alpha 1. Okay, this is the assumption. Okay, so let's say this point is forming phi angle. Okay, L1 and L2 intersect each other forming adjacent angles phi and theta. Okay, so let's say this is the phi and this is the theta they are forming. Okay, so for finding the angle theta, if we are given the slope m1, okay, and slope m2. Okay, if we are given the slope m1 and m2, okay, so we can find this angle theta by using this formula. Okay, that is tan theta is nothing but the slope m2 minus slope m1 upon 1 plus m2 times m1. Okay, by using this formula we can find the angle theta. Okay, same by using this we can find the phi angle, that will be nothing but the tan phi will be equals to m1 minus m2, okay, upon 1 plus m1 m2, which is written here. Okay, so by using these two things we can find the angle between both the lines. Okay, this will be the theta angle, this will be the phi angle. For theta angle we can use this thing, so here theta will be nothing but tan inverse m2 minus m1 upon 1 plus m2 m1. Okay, so by using this, and same we will write for this one. Okay, so by using this thing you can find the angle between any two lines. Okay, so if we talk about example, like there are many more which many more representation of the straight line. Okay, so this is basically what a general form of a line. Okay, ax by plus c, and this is nothing but if we write ax plus by equals to minus c. Okay, by equals to minus ax, okay, minus c. and y will be nothing but minus ax minus c upon b, and this minus a by b will be m, and this will be c. Okay, so this is nothing but y equals to mx plus c. Okay, same we have slope point form we have studied. Okay, same we have slope intercept form. When we are talking about y intercept, we can use this. When we are talking about x intercept, we can use this. Okay, this is the intercept form. If we are given to intercept a and b, then we can use x upon a plus y upon b equals to 1. Okay, and same we can use 2-point form. Okay, so by using all this thing, we can find the equation of straight line. Okay, for the given, according to the given equation, you have to use these all forms. Okay, so thank you. If you like the video, please hit our share and subscribe button. Thank you.